Welcome to IDS KT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today we are discussing a transportation revolution that could change the way we move between cities forever, the Hyperloop. Imagine stepping into a sleek pod, accelerating smoothly, and arriving hundreds of miles away in less time than it takes to watch a sitcom episode. This isn't just science fiction anymore. Driven by advances in materials, engineering, and sustainability, Hyperloop systems are moving from prototypes and test tracks into real-world construction. Over the next decade, these high-speed, zero-emission systems could reshape the global travel and logistics landscape. The market for Hyperloop is exploding. In 2023, it was valued at just over $2 billion, but projections show it rocketing to nearly $47 billion by 2032, with growth rates that outpace almost any other transportation sector. In the US alone, we are looking at a climb from $80 million in 2024 to hundreds of millions by 2030, and potentially over $12 billion across North America by 2033. The reasons are clear. Cities are growing faster than their transit systems can handle, and with more than 90% of the US population expected to live in urban areas by 2050, congestion is only getting worse. Hyperloop offers the promise of cutting journeys from hours to minutes, like going from Mumbai to Pune in just 25 minutes instead of 3 hours, all while producing zero direct emissions. Speed is the headline feature. Target velocities exceed 760 miles per hour, outpacing short-haul flights and potentially rendering them obsolete for certain routes. But cost-effectiveness is another game-changer. At roughly $54 million per mile, Hyperloop infrastructure is far cheaper to build than high-speed rail or maglev systems, which can run 2 to 4 times more expensive. And because the tubes require less land, routes can be designed with greater flexibility and fewer environmental disruptions. For freight, the advantages are equally compelling. Cargo pods traveling at over 600 miles per hour could revolutionize e-commerce, enabling same-day delivery between major cities, while reducing road freight emissions dramatically. Around the world, different regions are racing to lead. Europe currently holds the largest market share, with Italy's Hypertransfer project aiming for operational speeds of 1200 km per hour by 2030. North America is a hotbed of private sector innovation, with companies like Virgin Hyperloop, The Boring Company, Hyperloop TT, and Transport pushing corridor studies and test tracks despite regulatory uncertainties. Asia-Pacific, meanwhile, is the fastest-growing region, with India's Mumbai-Pune project and China's massive Chengdu-Beijing line both aiming to redefine intercity travel and, in China's case, even exploring military applications for Hyperloop tech. Technological breakthroughs are helping the concept move from dream to reality. Advances in hybrid magnetic levitation, AI-driven stability controls, and ultralight composite materials are making pods faster, smoother, and safer. Hyperloop TT has developed massive safety isolation valves capable of sealing tubes in 30 seconds, and companies are refining passenger comfort features to ensure a pleasant ride at extreme speeds. Partnerships and funding rounds in the hundreds of millions are providing the capital needed to move from test tracks to full-scale commercial systems. But challenges remain. Hyperloop technology doesn't fit neatly into existing transportation regulations, which slows down approval processes. Building and maintaining vacuum-sealed tubes over hundreds of miles is an engineering hurdle, and safety concerns, from emergency evacuations to cybersecurity, need clear, tested solutions. Public education will be vital to overcome skepticism and build trust in this bold new mode of travel. Looking ahead, the next 5 years will be decisive. By 2028, we may see the first freight Hyperloop corridors in operation, followed closely by short passenger demonstration routes. By 2035, intercity Hyperloop lines could connect major economic hubs, with stations integrated into wider transport networks that include autonomous vehicles and electric aircraft. And beyond passenger and freight transport, some envision Hyperloop tubes doubling as launch systems for space payloads, blending transportation and aerospace in ways we've never seen before. The Hyperloop revolution is no longer a distant dream. It's a rapidly approaching reality, fueled by global demand, technological innovation, and a shared need for sustainable, high-speed mobility. Whether it becomes a mainstream transportation backbone or remains an elite alternative will depend on the breakthroughs and decisions made this decade. One thing is certain, the world is not just watching, it's accelerating toward the future.